Consider the following statements. Correlation coefficient is a measure of proportion or percentage in relationship. So we have like correlation coefficient -1 less than or equal to r less than 1. This measures the strength and direction of linearity or linear association between two variables. So it is not a measure of proportion or percentage. Like for example, if r is 0.8, that doesn't mean there is 80% relationship. So therefore first statement is incorrect. The second statement says statistic z square is an equivalent measure of statistic chi square. So we know that if z follows normal, standard normal 0, 1, z square follows chi square with 1 degrees of freedom. So thus the square of a standard normal statistic follows chi square distribution with 1 degrees of freedom. So the second statement is correct. The third statement says t distribution becomes mesokurtic when degrees of freedom approach a very large value. So the degrees of freedom, as they tends to infinity, we know that t statistic tends to normal 0, 1, and normal distribution is mesokurtic because the kurtosis of normal distribution is 3. So therefore the t distribution becomes mesokurtic for large degrees of freedom. So third statement is correct. Fourth statement says 1 minus alpha significant points of f distribution are same as the reciprocal of 1 minus alpha significant points of f n1 comma n2 distribution. So for the f distribution, like f alpha n1 comma n2 is given as f 1 minus alpha n2 comma n1. So we notice that the probability level is changing from alpha to 1 minus alpha. So the statement claims the same significance, 1 minus alpha on both sides, so which is incorrect. So statement 4 is incorrect. So option A will be the correct answer.